Hi, I'm Faraz. I am not a nuclear engineer. I am not a nuclear scientist. I have no nuclear training, but I'm curious to see, do I have enough knowledge to become a nuclear engineer? I'm going to take a test on nuclear engineering, and I'm going to see how well I do. I'm not going to study for it. I'm not going to read on it. I'm just going to see, do I know anything about nuclear science? My only real exposure to nuclear science is through The Simpsons. I don't have a lot to go off of here. I do think I'm pretty good at physics. I'm maybe okay at chemistry, but that's kind of the base knowledge I'm working with here. I found on MIT OCW a class called Engineering of Nuclear Systems. And hell if I know anything about this topic. Okay, so here's the exam. I'm just gonna start. For each of the following drawings, identify the components by the red arrows and describe in one sentence their function. Oh my god, this exam started rough. I don't know what that is or what purpose it serves. That's not a nucleus. But it looks like fluid is flowing through those tubes, those radial arrows over here. So I'm gonna guess that that's like coolant fluid. And then what is that? Looks like a release valve. I'm gonna guess that's a pressure release valve, so to release steam pressure. Okay, wait, what is the central node? That looks like a vent. Is that where the nuclear reaction actually happens? Yeah, I don't know. I don't know. Let's move on. Cross-sectional view of a power fuel pin. I assume PWR means power, but it could very well be an acronym. I remember learning in some physics class that they would use carbon coolant rods to try to reduce the rate of the nuclear reaction. I think the inside is made of carbon. I don't know what the outside is made of. I didn't know there was an outside. Its function is to absorb radiation. What is the outer thing? It's probably made of metal. Right? It's a casing. It looks like a casing made out of aluminum. I don't know. What is its function? To prevent the carbon from breaking? Like a pencil? I mean, what is it? What is its function? That looks like a hand. Okay. So this looks like a cross section of the actual reactor. That looks, okay, this is something that I can maybe parse. So that here looks like the turbine. And so these arrows represent the steam moving through it. It powers the turbine, that's its function. And then what is that? That might it be the condensation rods where the steam condenses? Oh yeah, that makes a lot of sense. Look at that blue arrow. Maybe that goes back into the nuclear reaction. That kind of makes sense to me. So that's how they try to recycle the steam. That makes sense to me, I think. Let's move on. What are these? What? These look like a biological pipette rack. They like take the pipette tips from the boxes. This looks like that. How much are they gonna ask about cooling rods? Now we're at the open book questions. Well, I don't have a book, so this looks like math, and I think I'm pretty good at math. Is there a formula sheet? There's no formula sheet. Okay, that's gonna be really difficult then. A nuclear reactor in a submarine delivers 18 megawatts of shaft power
equals
on a
x
cruising
squared.
speed of 20 knots. 1 knot is 1.8
x
times 10 to the
squared.
minus 19. If the power plant has a thermal efficiency of
equals
25%,
mc squared.
how much
Joule
a
is a
kilogram of 235 uranium
per
fuel
square.
is 7.2
Equals
1.62 times
squared.
4.6 times 10 to the minus 3 kilograms. T equals 5.25 hours. 4 phi sigma S A over M. Pi r squared Q naught triple prime 1 plus A over 2. TFO plus KF times Q prime. 8733 Okay, now we have to go back to the beginning and see if I can figure out any more of what these things are. You know, no, I give up. I don't want to think about nuclear science anymore. Number 1, wrong, definitely wrong. That feels right. And that last thing I got wrong. I think it's correct. Wrong. Well, no, wrong. A partial credit. Oh God, no, wrong. All of this wrong. Off by 1,000. Wrong. So wrong. Oh my God, I got that right. Oh man, that is wrong. That is so wrong. Nope, also wrong. So I got half a point here, half a point here, and 1.5 points here, 10 points here. I have gotten 11.5% on this nuclear science exam. Now that I'm done with the exam and I've seen how badly I did and all the mistakes I made, I want to go back and highlight all the times where I should have known better than to do what I was doing. I was really obsessing with cooling rods on this exam, and I was like trying to shoehorn it everywhere. Carbon coolant rods. In reality, it's called a control rod. At this point in the exam, when I guess PWR means power, I assume PWR means power. Why did I say cooling rods? Cooling rods are the exact opposite of power. They're trying to reduce the nuclear reaction. So why didn't I realize that these two things are opposites? I should have known better then. And at this point, I begin questioning my obsession with cooling rods. How much are they going to ask about cooling rods? And I was almost there. Then on the submarine question here, I thought I was being really big-brained for using E equals MC squared.
E equals MC squared.
I have seen E equals MC squared being used in my chemistry class when they're talking about nuclear reactions. I don't really know the details of why E equals MC squared doesn't work here. So for this question, I got 8,700 Celsius as the temperature of the rod. 8733. That's hot as fuck. But I know that the temperature of the sun is 5,600 Celsius. I should have realized that I cannot have a rod hotter than the sun. I should have realized that was wrong. Basically, in this video, we learned that I am very stupid and that I should not be trusted with anything related to nuclear science or technology. Thanks for watching, guys.